Okay, so welcome to the 12th and final part of our shoot 'em up using Pygame, Monogame and Love2D. This is the Pygame version. So we have, as before, a menu, and the final changes that we're doing today is the introduction of a leaderboard. So I'll start the game off by pressing enter, and then I'm going to pause until I'm about to die. Okay, so we're almost on obliteration. We're down to our last life, so up comes the leaderboard. So these are previous high scores that you can see. They're in descending order, so the top score at the top and then going down, and it only allows 5 to be displayed. So I can type my name. There's no cursor, you just have to press the keys. So if I save this one as test, I can backspace and delete a key, and I'll call it, I can put a space in, so I can call this test 1, and when I press enter that should record my score. There we are. So test 1 is now recorded at 1, 2, 3, 4, 4 from the top, so not too bad. And then I can press C to continue, and then we get another game to see if I can beat the current high score, which of course is 4,904. So if I press C to continue, we're back to the menu and off we go again. Press escape here. As you can see, the score was reset to 0, 3 lives, and at the time the shield was in full, but now of course it's gone. Okay, so that's the leaderboard. Right, so how does all this work? Let's start with the leaderboard itself. This is quite a complex class. In the Pygame version I have made it a full class, even though as there's only one leaderboard we could have got away with a static class. But you'll notice immediately that we have this slightly unusual step of a nested class. So I've got this class leaderboard with all its normal constructor and whatever methods that are available in it, but I've also got this separate inbuilt class, which is kind of a subclass, a nested class called score data. Now the reason for doing this is that when you have finished, you've ended the game, you will have a score of, let's say, I don't know, a couple of thousand, and you want to enter your name into the existing scores, the kind of original database. So you want to enter both your name and a score. So this was kind of the easiest way to do it, was to have this internal class called score data. It has its own constructor, and it takes a list or tuple. Although I've defined it here as a list, it could be a tuple. So that's what we're going to be passing in to the constructor, and that will consist of the name of the person who has just played plus the score that they have just achieved. So what it does is just to have a self.name and a self.score, and then if we want to get that data back out of the class from each score data object, we might need it in 2 formats. The first would be to write to a file whereby we would want the name and the score separated by a semicolon with a new line character afterwards. So this is to write to the high score text file, which you can see if I just increase the helps if I press the control. There we go. So that's a sample of our high score file. So it's got the names and the scores. So let's go back to where we were on leaderboard. So if we wanted to write to that file, we can go through the score data objects, of which there will be 5 if there's been at least 5 people playing, and write into it this single line of text, which is the name, semicolon, score with a new line character. So that writes it to the file. We also might want to display it in the leaderboard, so we would want it slightly differently there. We would want to have the name maybe with a space, then a colon, and then another space, and then the score for presenting on the screen. So using the same data, but we've got two return types. They're both string, but one will be slightly different from the other depending whether it's going to be displayed or whether it's going to be written to a file. Now this constructor here, although it's not immediately obvious, we can supply either that line as a tuple, where we could supply the name, comma, score, or as a list, and it uses the same syntax to get the first and second part of that tuple or list. So this is a sort of a clever bit about Python. You can supply what you like and still get the information out of it. You will note a difference in this in the C# Monogame version, but as far as Python's concerned, we can supply that piece of data. It's separated out into a name and a score, and that is then used when required. So let's go through how this works. So when we first start up the leaderboard, it won't jump to the score data. It'll go to its personal constructor here, and then we will get these various variables set up. So has the current player entered their name? Then we have an empty list which we'll call score list. Now this will be a list of score data objects. So we will be creating a number of score data objects and then storing those in this list. Then we've got the name that we're waiting for the player to type in, and then we've got this Y position of 80. So this is where, when we're displaying the leaderboard, that will put it out. Now I just want to do something here. I'm going to go back to the main one here and show you, or remind you, that the way this was set up in the let me see, it was the one that gets the text input, if I can remember where that is. No, it escapes me for a moment, but anyway, let's start that up. And if you recall, if we press the debug one, which is X followed by L, we actually go straight to the leaderboard. This is purely for testing purposes, so it's of no practical use, and that's why it's not been sort of highlighted that you can do that. So this allows us to kind of go through and test and check out that the leaderboard is working. So you'll see that we've got the 5 names in the correct order with leaderboard at the top. So if we just get rid of this thing here, so that's all done in the leaderboard's draw function. So we draw the word leaderboard. If I can just bring that back up, there we go. So we draw the word leaderboard in yellow, and then we're going to go through our score list, and from it we're going to take each of the score list get score data for display. So this is where, from each of the objects inside the score list, so this will be objects of type score data, and each of those objects will contain just 2 properties, name and score, but we've got this built-in function that will return the data that's in there in one of 2 formats. So down here, when we're on the draw screen, down here, we're asking it, the self score list, to use the get score data of type display. In other words, it will be specifically asking for the display data, which is not file. So it's obviously just this one. I could have put an elif dest equals display, but in this case there was not necessary. So we will get this one returned, which is the Fred colon to 500, which you'll see on here. So we've got Fred colon to 844. That's our score. So in the draw function, we are getting each of the score data objects, and from its built-in get score data, we're getting the string of the two of them put together for display purposes. So that's how that works there. Now, we're assuming that you have just entered the leaderboard because you have just died, then it will be showing you that score list and asking you, as it is here, to type your name and press enter. So this would be sitting there waiting for you to start typing stuff in. So if we look in the update function, you'll see that we've actually in here got the section of code that gets what you're typing in. So if the self current player entered has not happened, in other words, we have not yet entered the current player, then every update cycle this section of code will run. So it's waiting for you to type stuff in. Then there's a little if statement here to check whether we've actually hit a key down, just to save a bit of time. So if we've not hit a key, then it ignores this and goes on to the next frame. If we have hit a key, it's checking whether it's what it is. If it's the key backspace, then obviously it will shorten the length of whatever text that we might have already typed in. So it uses self.name, which we set up here in the constructor, as an empty string. So when we're updating, if you type in a key, it will add to what's already in the self.name by using this section here. So it will check if you're pressing the backspace key, it will remove something from self.name unless the length of it is 0, and then it will set self.name to an empty string. If the key that you've typed in is a genuine ASCII key between including all the letters of the alphabet and I believe some of the symbols also fit into the ASCII 127, then it will add that key character to our self name. So our name will increase every time we press down a legitimate character. But this is also checking for whether we hit the backspace to remove a character or the enter, because that means we've finished putting our name in. So this will run during the update cycle while this screen here is working. So if I press, let's say, test again, let's call it test 2, then every time I did that, it's checking here to see what key we've typed in, and then it's added it to the string and increased it here. If I press a backspace key, then it uses this one and reduces it right on until if I delete it all, then it will just give it an empty string. So this is how through the update, this is how this drawing in this box is handled. If we finally hit the enter key here, then first of all it's going to check to make sure that after stripping out any spaces at the beginning or end of it, that it is greater than 1. That will stop you from being a bit of a plonker and as I can do here, delete everything, and then press the space key 5 times. 1, 2, 3, 4, 5. Although you can't see it on here, we know that that's actually spaces. Now I'm going to press enter, and nothing happens, because it has realized that after we've stripped out all the spaces, then we haven't got any characters in there, so that is not valid. If we have got past that player entered, so once I've pressed in my name, let's put that one back in again, let's put test2 and pressed enter, then that means that the current player entered is set to true, and then we are asking it to add an entry. So let's check what add entry does. As you can see, the screen is still operating, but it's just waiting for us to press the C key, which it checks if the current player has been entered. Then we're checking to see whether the C key has pressed. Then it will go to the menu screen there. So let's check what add entry does. So when we've hit the enter key and we've typed in, as we did before, test2, it's going to make a temporary object from our score data class. So it will call the score data class and store it in this variable called temp score data. So this will have an object of that type, and it's passing a tuple. You can see you've got the double brackets here, so we're passing in a tuple consisting of self name, comma, shared score. So we're passing a tuple. I could just as easily have put that in with square brackets on the inner set, but I've just passed it in as a tuple. So that will go up here and create our object containing the name and the score. So it will now have in it test2 and whatever score I happen to have scored in there. Now what's happened here? I didn't think I'd pressed any keys. Anyway, let's go back to where we are, or where we were. I've no idea why that suddenly popped up, because I wasn't doing anything. How peculiar. Right, anyway, let's go back to where we were. So we were adding an entry. That's right. So we've got this entry created, and then it's then calling self insert data temp score data. So we've created an object of score data, which consists of the name and the score, and then we're going to insert it using this insert data one here. So let's see what insert data does. Now insert data takes our score data that we have created up here. Remember we had this temp score data, so we're putting in that temp score data, and it's going to assume initially that it's going to put that new data at the end of our list. So if I hover the mouse over here, we'll see that the current score list consists of 5 objects. You can see them listed in the tooltip there. We don't get a lot of detail from it, but we know there are 5 objects in that list currently. So we're going to assume that it should go at the end. Now what we're doing next is we're going through that entire list to check whether the current score data that we have just achieved is greater than or equal to the current data that's in the list already. So if it is greater, then we're going to change the insert at, which was originally set at the end, to whatever the current value of I is. So if we've got a very good score and it happened to be better than the top score that's already in there, then it's going to put insert at will be at the kind of top place, starting at 0. So it's insert place would be 0. If it's not greater, this loop will continue until it either finds a position where it is greater than the current one in the list, or the loop will simply finish, so that I will be given a value either at the end of the score list or at some point during it. So that allows us then to insert into the score list using the Python insert value here, and we're going to insert it at that list, that position given by I here, so that if it's still at the end of the list, then we put it at the end of the list, and in it goes. So this way we are constantly making our self.score list to be kept in the correct order, with the highest score at the top and the lowest score at the bottom. So it kind of sorts and inserts at the same time. There's probably ways of doing this without all this faffing around, but I wanted to try and keep this principle going through all 3 versions. Now, as I say, I'm not quite sure why the program has crashed here. It says it can't access the highscore.txt. I've absolutely no idea why that would have occurred, and especially as we're not actually trying to write into it at this stage. But anyway, no worries. It means that this has died on us. So, yep, no problem. Okay, so we'll close that. So that's showing you how the high score list works. And then once you've entered the high score, it will then, let me show you how it's then written to the file. So if you recall, in the update one, we were checking to see whether the player has entered their name, and if they have entered the name, then it will store it in the name by initially passing it to the insert at, which is done here, and then we write it to the file by going through we have to open the file here using the highscore.txt, which is this one here, which is located at the shared game folder, which of course is the current directory that we're in, and then it's going through each of those in turn, counting as it goes how many lines we are writing by having a line starting at 0 and then increasing that by 1 each time, so that we write a maximum of 5 lines into that text file. So we're just using the conventional write there, and we're writing it into, this time using the get score data of type file, so that each object in it is now going to be written using this return, which is Fred : 2500 \n. So that's how that writes to the file, and then when you use the leaderboard at the next time round, it's going to reload that list to see what is in there, and then allow you to add your name and overwrite it if that's the case. So it's a fairly complex piece of code here. I've put lots of comments in. The best way of doing it to see how it works is, especially if you're using something like Wing, is that you can put stop points in and see what happens, so that you can kind of trace it all through. Just give you a quick demonstration of that as it's crashed. We've got to start again. Let's hit, oops, wrong one, cancel. Let's go to the tutorial, hit that. We're going to press the debug key, then L, and this is why I did it this way, so that I can debug it. Now we're going to put in test 2, and this time, let's get this out of the way, I want to catch this when we press the enter key, which will be in the update one. So if the key down is return, it should get us there. So let's hit return, get this out, press enter, there we are. So key down equals Pygame return, it does. So self.name, as you can see, probably just under the, as I pass the mouse over it, is test2. So it's got the name that I entered. Let's go through this. F7. So we are now going to set self current player entered is currently false, as you can see just under the mouse there. F7, it's now true. So we've done that. Now we're going to add the entry. So it's gone up here. So we're now going to create an object of type self score data, passing self.name, which is test2, and the shared score, which of course is 0 this time because I just cheated and went straight to the leaderboard, so my score is 0, but fair enough. F7 again, and it will go to the constructor of our class score data, and it's passing in this line, which is, as you can just about make out, I'm sorry I can't increase the font for that, but it says open quote test2 close quote comma 0. So that's our tuple. So self name, which is currently empty, is going to be made into line 0, which will of course be test2. So let's press F7, and I'll press F7 once more. So we've now got self.name is test2 and the score is 0. F7 again will come out of the class. So we've now got this temp score data, which is now just referred to as an object, because it doesn't, if this was in C# you'd be able to see the contents of that object, but unfortunately all it gives us in Python is a memory address. But no worries, we've got the data in there. And then it's self insert data, which we're going to do now by pressing F7 again. So we're now using the insert data, we're passing the score data, and we're going to put it at the length of the score list, which I believe is 5. So let's press F7 again. So insert at is now set at 5. So that's our insertion point. We're going to put it in at 5 unless the score is so good that it allows us to insert it in earlier. I won't step through this entire, well, yes, I might as well, because it doesn't take too long. So at the moment it's not finding something that is greater than the current score in that list. So of course it's just flicking up and down, and once it's finished we're now going to insert it at 5. So we're going to put it at the bottom of the list. So we now press F7 again. So that's done its job there, and we're ready for the next update. So we're now of course dropped back into the main thing there. So it's now going to show from now on the C key, because that has been accepted. It's there, it's running and going. So we'll just press the continuation, and of course we're now waiting for the C to continue. Might as well finish this off as we were tracing it. So now we're going to check whether the key passed is C, which I will do by hitting the C key. There we are. The key down was C. So the game state, which is currently at 2, is going to be set to game state's menu, which as you can see is 0. So we're now going to go into game state 0. Self current player enter, we're resetting it to false, ready to go, and let's press the green again, and of course now we're showing the menu. We've come out of the leaderboard state. So you can see how the leaderboard works. This is a fairly complex piece of code here, but I think it's been helpful to show you how you can step through, even in Python, to see what state things are in, what to expect, how things work. The only thing I haven't gone through is how we draw, let me shut that off for you, that box that you're typing into. I've added into the shared here this extra function called display box. So we already had draw text, we've now got a display box. So all that does is it draws a box that when we type in, it puts the text in the box. So there's a lot of parameters that you're passing, as you can see. So it gets the font from this Pygame font thing, and then takes the size, which we have passed in, and then it draws initially a rectangle on the screen, which would be because it's set to 0, that would be a filled rectangle. So we fill the rectangle in with the back colour, which is dark, if I remember right. Yeah, here we are. So the back colour is dark blue, so we fill it in with dark blue, and that draws our rectangle. And then on top of that we draw the outline, because it's set to 1 pixel down here, similar size rectangle, so that draws our rectangle. And then the text, if there is any, if it's longer than we've actually got some text there, it draws the text into the same coordinates using the draw text there. So that's how that all works on the left hand side of the same box. So that I've put into shared rather than into the leaderboard itself, because it's quite possible you might want to use something similar at some point in some other part of your game or in the menu, or so by putting it in shared it's available to everything rather than it being restricted to just the leaderboard one there. So that was the other thing that I needed to show you. I don't think anything else matters. Oh yeah, in the main files here, obviously in the update we're also now checking if the game state is leaderboard, then of course you'll update the leaderboard. The list of objects here now includes a leaderboard object, and of course we are passing in or importing the leaderboard. Then in the load function we are creating an instance of the leaderboard class and calling it data.lb. Again, because it's being shared, it allows us to do that. I suppose I could have done, just thinking about it, I was grumbling about having to use this global player here, and I want to get rid of all global things. So in fact, yep, I'm going to do that right now. So it's on stop. So just to, if I control X that, whoops, control Z, or control X, that's better, and then we'll put it up here so that the player is now part of the data class. Class data is now including the player. That means in my load I can get rid of global player, yay, and then I can put down here data.player. The only thing is that means every occurrence of the word player that I've got in this script I would need to prefix with the word data. So we're losing something, we're gaining something. So probably, yeah, there's quite a lot of references to the player, so maybe that wasn't a good idea. Yes. It's a tough one, and it's all caused by this nonsense that Python has of not being able to recognize that something written here in the margin at the top of the script is genuinely a global variable. So it looks like I'm going to have to reverse what I've just done. But anyway, I hope you've enjoyed that, and that this whole series has given you the inspiration to start making your own game, and in a language of your choice. My personal preference was Love2D. I'm really coming round to Monogame now, realizing just how powerful Monogame is, and we've only just started dabbling into the physics engines and that kind of thing that are incorporated to Love2D. Pygame is kind of a bit old. It has its purposes, it's done well, but it's now getting old technology, so If you're insisting on staying with Python, then fine, that's for you, but move on. There's a lot of third-party libraries available in Monogame and in Love2D, and they can get extremely powerful things done there. So we're done for Pygame.